Okay, I'm going to introduce what's called antidifferentiation and integrals, okay? We're going to assume polynomials. So the rules are similar to what you'd be doing in any other function, but if the function doesn't involve polynomials, these rules have limited exceptions, which we'll get to when we do functions that are not polynomial based. Polynomials or monomials, those sorts of things. Okay, so in differentiation, we're taking an expression and finding its derivative. In anti-differentiation, we're taking something that we're treating something like a derivative and asking what is the function of, what it came from. Okay, so for instance, in a derivative, you go down a power. The original exponent becomes a coefficient, and the power goes down 1. In anti-differentiation, we go the other way. The power goes up 1, and instead of multiplying, we divide. Okay? Now, we are going to be following this document loosely. Okay? I decided that in this format, this video format, I would have corresponding rules to connect the derivatives and antiderivatives. So there's going to be some things on the board that are not here. Likewise, I'm not going to include I'm not going to cover everything that's on this document. Okay, so here goes. Given lowercase f of x is x to the 4th, find its antiderivative, capital F of x. Here goes. So capital F of x would be, we go up a power to x to the 4 plus first, following this rule, over with the new exponent also becomes a new denominator. Okay? So capital F of x is x to the 5th over 5. Up a power, and the new power is also the denominator. Okay? Or, put another way, capital F of x is sometimes written as 1 over 5 times x to the 5th. Both of these are equivalent. Note, now we're going to differentiate. Note, dx of 1/5 x to the 5th equals 1/5. We're taking the derivative of this. So it would be, derivative of x to the 5th would be 5 x to the 4th following the differentiation rule. Okay? So d dx of this is x to the 4th. Okay? So if you take the derivative of this, you get that back. Okay? So differentiation and anti-differentiations are the undos of each other. Okay? So note, the derivative of that is what we started with. Okay, example 2. Given lowercase g of t equals 202t, find antiderivative capital G of t. Okay, lowercase, the antiderivative is the uppercase. So here goes. Do capital G of t would equal, because it's the antiderivative, G of t would equal 202. We're going to go up a power. This was t to the first, so this will be t squared. And the new power on top is also your denominator. Okay, we're basically following these two rules at the same time. So, 202 divided by 2 leaves you 101. So 101t squared. Notice that if we took the derivative of this, we would get 202t to the first if we took the derivative. Okay? With respect to t. All right, if we took the derivative with respect to t, it would give us 2 times 101, 202, which would be at t to the first. Okay? Note, dt of 101t squared would be 101 times 2 t to the first, 202t. All right. Example 3. Given g of x equals 105, find antiderivative capital G of x. Do. We are told that the variable is x. Okay? We're told the variable will be x. The antiderivative of a constant is the constant times x. Okay? All right. What's this used for? Integration. Okay, so I'm going to clear the board and resume with integration. Okay, what's called the Riemann integral. There are multiple types of integrals, but the Riemann integral is the antiderivative plus capital C to account for a constant. Unless given reason to assume otherwise, the integral means the Riemann integral. Okay? So we're going to go ahead and do it with this problem right here. Okay, so we're going to follow the anti-differentiation rules with every term. So this will be 3, and then there's the antiderivative of x squared. Well, that's going to be x to 2 plus first. Sorry. I'm going to start that over. Okay, this is going to be 3 times x. We go up a power to x cubed over 3 plus 22. We go up a power from x to the first to x squared, and the new power on top is also your denominator. And the antiderivative of my constant will be the constant times x, and then plus the c to account for a constant. Okay? So these cancel, and we end up with x cubed plus 22 divided by 2 is 11, x squared, plus 7x plus c. Okay? All right. Example 2. The integral of 10t to the fifth minus 84t cubed plus 9t minus 1 dt. Okay? So what this is we have 10, and since we're anti-differentiating with respect to t, we follow these rules for the t. So this will be t to the 6th over 6 minus 84. We go up a power of t to the 4th over 4 plus 9. We go up from t to the 1st to t squared, and the new power also goes on bottom, minus the antiderivative of 1 will be 1t in this context, and then plus your c. Okay? 10 divided by 6 leaves me 5/3. 84 divided by 4 leaves me 21. So I will have 5/3 t to the 6th minus 81 t to the 4th plus 9t squared over 2 minus t plus c. It may look different than what's on the paper, but that is okay. Okay? Example 3. I want the integral of 34x plus 15 dx. Folks, the parentheses don't matter. It's the same idea. So we will have 34. We go up from x to the first to x squared. And the new power on top is your new power on bottom. Plus the antiderivative of the constant with respect to x would be the constant times x. And don't forget the constant to account, the capital C, to account for any constant that might be there. So 34 divided by 2 is 17. So we will have 17x squared plus 15x plus c. All right, let me pause this and move on to something else. All right, now what we're going to talk about is what's called the definite integral. Okay, this is the indefinite integral. Okay, there are no boundary values specified. This one has boundary values specified. So what you would do is you would find the antiderivative and you'd plug this b into the antiderivative, a into the antiderivative, where these represent your antiderivatives. And then you would subtract. The steps are more explicitly stated on in this document that we're referring to this video lesson on. Okay? So the steps are there. To save space, I'm not going to rewrite them. I'm going to rewrite it in a different format here. Okay? So what you would do, this integral has boundary values 1 and 3. Okay? So what we're going to have to do is we will still find the antiderivative. This will be 35. This will go up to x to the 5th over 5. Plus, this is 18, and then you're going to go from x to the first to x squared. And the new power on top is also your new denominator. And the antiderivative of 4 with respect to x would be 4x. And we're considering this as we go from 1 to 3. Okay? So what we would do is we'd still simplify this. 35 divided by 5 is 7. So 7x to the 5th. 18 divided by 2 is 9. Plus 4x. As we go from 1 to 3. Okay? What we do now is we plug in 3. We'll plug in 3, calculate. Plug in 1, calculate, and subtract. Okay? So x equals 3. I have 7 times 3 to the 5th plus 9 times 3 squared plus 4 times 3. Okay? So that's going to give me 3 to the 5th is 243 times 7. That's 1701, I believe. We're going to double check. 7 times 3 to the 5th. 1701. Okay? 9 times 9 is 81. Plus 12. So 1701 plus 81 plus 12 is 1794. Okay? Next, having done that, we'll plug in 1. Remember, it goes into the antiderivative. So that's going to be 7 times 1 to the 5th plus 9 times 1 squared plus 4 times 1. Okay? Well, 1 to the 5th is 1, so that's 1 times 7 is 7. 1 squared is 1 times 9 is 9. 4 times 1 is 4. And this gives me 20. Okay? So, having done that, we take this and subtract. We take the result of the 3 and we subtract the result of the 1. And that gives me 1774. All right. Now pause. Okay, example 3. We're going to we're going to take f of x equals 56x cubed minus 46x plus 17. And we're going to find these 3 things. The derivative, the indefinite integral, and the definite integral as x goes from 0 to 8. Okay? So with the derivative, we will follow the same rules that we did before. So that's going to be 56 times 3x squared. We're following the differentiation rules. Okay? Minus the derivative of minus 46x would be minus 46, and the derivative of 17 would be 0. So f prime of x is 56 times 3, 168 x squared minus 46. So that's the derivative of this function. B asks for the integral of this. So we're looking for the integral of f of x, and f of x is this. With respect to x. Okay? So now we'll follow the anti-differentiation rules. So this will be 56 times x to the fourth over 4. Go up a power and make it your new denominator. Minus 46, we go from x to the first to x squared over 2, plus 17x is the antiderivative of a constant with respect to x, the constant x, times x, plus c to account for the arbitrary constant. Okay, because it's an indefinite interval. So, we have 56 divided by 4 is 14. 14x to the fourth. 46 divided by 2 is 23. And that is the indefinite interval with respect to x. All right, now I pushed the board a little bit back, or pushed my chair and computer a little bit back, and now we're going to do C because we're going to need a little bit. We're going to need as much space as we can get. So C is going to be the definite integral with respect to x as we go from 0 to 8, and f of x is this. So it's going to be the integral as we go from 0 to 8 of 56x cubed minus 46x plus 17 dx. Now, what we're going to do this, so it's going to be the same thing. We find the antiderivative, similar to what we did there. So this is going to be 56. We go from x cubed to x to the fourth, and the new exponent is also a denominator. Minus 46. We go from x to the first to x squared, and the new power of x is also your denominator. And then the derivative of the constant 17 with respect to x is 17x, as x goes from 0 to 8. This time I chose to use a straight line instead of a square bracket. It has the same significance. Okay? You're going to find the antiderivative, and you're going to plug those numbers in and subtract. Okay, so I'm going to finish the antiderivative. So this is going to be 56 divided by 4 is 14. X to the fourth minus, let me write it a little lower. 56 divided by 4 is 14. X to the fourth. 46 divided by 2 will be 23, so we'll have minus 23. X squared. And then plus 17x as we go from x equals 0 to x equals 8. So at x equals 8, we will have 14 times 8 to the fourth. We plug it into the antiderivative. Minus 23 times 8 squared plus 17 times 8. 8, 8, 8. So 8 to the fourth is 4,096 times 14. 57,344. 64 times 23 will give you minus 1472. And then 17 times 8 is 136. So 57,344 minus 1472 plus 136 gives me 56,008. Okay, next I'll plug in x equals 0. So that's going to be 14 times 0 to the fourth minus 23 times 0 squared plus 17 times 0. 0 minus 0 plus 0 is 0. So I will take the result from 8, 56,008, and subtract the result from 0. Antiderivative with h minus antiderivative with 0, which I got 0. So 56,008. Okay? Again, we don't include the plus c on the indefinite on the definite integrals because they will cancel under subtraction. Okay? The handout has a little bit more detail on that with the previous example too. Okay? All right, so that's the big picture. Know when you're doing the derivative. If it's out prime of x, you follow the derivative rules. If it asks for the antiderivative, you will be following antiderivatives. You'll be finding antiderivatives. Okay? Integrals are antiderivatives, always. Okay? All right, I want to close with another type of integral. Okay? Or instead of the Riemann integral, we're going to talk about the Riemann-Stieltjes integral. In the Riemann-Stieltjes integral, we're integrating a function with respect to something other than x, but which is based on x. So, for example, you might see something like this. A function of x with respect to maybe a derivative of x squared, dx squared, or something like that. Okay? Basic examples like this are understandable in 100 level classes. Typically, the Riemann-Stieltjes integral is saved for maybe graduate programs or upper level, like 300 or 400 level classes in colleges and universities. But basic polynomials with something like this, you guys can understand these if you can understand what we've been doing. So we'll go ahead and introduce one, a Riemann-Stieltjes integral. So what you would do is you would start with taking the derivative of this. So dx squared is simply derivative of x squared is 2x, but you'll keep your dx. Okay? So what we would now have is the integral as x goes from 0 to 1 of 6, we'll put in parentheses, 60x to the 4th plus 18x squared plus 7, 2x dx. And then it's simply going to be a distributive property situation. Okay? So you'll have the integral as x goes from 0 to 1 of 120 x to the 5th plus 36x cubed plus 14x. And then you'll keep the dx. I'm going to pause for just a moment. Okay, and then from there, I just follow the normal anti-differentiation rules. So we'll have from x going to 0 to 1. So this is going to be 120. And this is going to go up from x to the 5th to x to the 6th. And your new power on top is also your denominator. Plus 36. We're going to x to the 4th. And we'll have a 4 on bottom as well. Plus 14. This goes from x to the 1st to x squared over 2. I'm going to move this down, these brackets down to make everything look more aesthetically pleasing and understandable. 120 divided by 6 is 20, so we'll have 20x to the 6th plus 36 divided by 4 is 9, x to the 4th, 14 divided by 2 is 7, and then we have x squared. Okay, so at x we'll plug in 1, so this will be 20 times 1 to the 6th plus 9 times 1 to the 4th plus 7 times 1 squared. So 1 to the 6th is just 1 times 20 is 20. 1 to the 4th is 1 times 9 is 9. 1 squared is 1 times 7 is 7. So this ends up being 36. Okay, next we plug in the 0. So 20 times 0 to the 6th plus 9 times 0 to the 4th plus 7 times 0 squared. 0 to the 6th is 0 times 20 is 0. 0 to the 4th is 0 times 9 is still 0. And 0 squared is still 0 times 7 is still 0. So 36 minus 0 is 36. Okay? And that's it. I'm done.